Can I use this one? Or? Sure. Okay. I'll just saves me 10 seconds. Uh, Hi, welcome everyone. My name is Venkat Guruswami. I'm a senior scientist here at the Simons Institute, and I'm also co-organizing a program on error correcting codes, theory and practice next semester. And I have a great team of co-organizers, Mary Wooters at Stanford, Henry Pfister at Duke, Shivakant Gopi at Microsoft Research, and Jill Zimmer from University of Bordeaux. And this is going to happen alongside a program on quantum fault tolerance, which is a really great opportunity because quantum error correcting codes are really becoming an important topic now. So I don't have slides, but briefly, what are error correcting codes? We all know and use them. They protect data from noise. It's a classical field which originated in information theory, electrical engineering, but now cross-cuts doubly computer science, math, and physics. And of course, is hugely relevant in practice of, whenever we store or communicate data, or, soon when we'll be doing quantum computers. So there has been, and again, along the side, the goals of the Simons Institute, there's been a flurry of progress along all these axes. We have now algebraic codes, which get to capacity in worst case and random models. We have a very interesting progress on local decodability of codes. Polar codes are amazing and already in 5G within 15 years of discovery. And a lot of progress on the mathy aspects of coding theory and breakthroughs on quantum LDPC codes, which are also very exciting. And as I already mentioned, on the practical side, Polar codes are in 5G. Locally repairable codes have made it big in data centers and cloud storage and heavily in use every day. And quantum codes are really knocking on the door and will hopefully make large-scale quantum computing a reality. So the program is really catalyzed by these rich developments and brings together a wide variety of researchers from CS, math, and EE, and also industry partners. And I want to, especially for this audience, talk about the synergy with practice. Error correcting codes is a really unique field in the sense that new technologies give rise to new theoretical problems which we can study, and some of these are really fundamental, and these solutions then feed back to practice. And there are many examples of this, and so that's what makes this field very unique. So we really welcome and look forward to lots of connections with industry in the next semester. And with this in mind, for example, one of the workshops, I didn't talk about the workshops, but one of the workshops, all the programs have 3 workshops and a boot camp. And one of the workshops is actually going to be earmarked for application-driven coding theory. And our hope is that also to take advantage of the fact that we are in Silicon Valley and there are lots of companies interested in novel technologies to process and data reliably, to get new kinds of problems where we can really collaborate. And there might be other fora like specific brainstorming industry days also, which we might plan. So that's in planning. And the other synergy I want to mention is with the quantum program. In quantum computing, in some sense, the error correction is really the burning question and the stumbling block to make scalable quantum computing possible. And there's lots of exciting developments on that. So we will have a joint workshop with the other program to really, increase the synergy, and also have the boot camp will be joint as well. So that said, I'm really looking forward to an exciting semester of research, discovery, and hopefully a lot of impact and synergy with practices.